Okay, hi everyone. I'll keep this short and we can discuss anything in the poster session for any follow-on, so I'll just go through quickly. So our work is more of a demo paper, really. We are focused on building an end-to-end full-stack framework for running simulations easily, and in particular multi-agent simulations focused on negotiation scenarios. So these are just some of the requirements that we started from. So we wanted to focus specifically on negotiations, so not general multi-agent scenarios, but specifically negotiation scenarios. It needs to be configuration driven as much as possible. This means there needs to be some sort of succinct domain-specific language for configuring both agents and the simulations themselves. And we want to implement agent-specific utility. So in the course of this workshop, and in doing the research for this work, we sort of reinvented the wheel. It's been great to learn about what people who have worked in this domain for a much longer time have done, and we will take away these learnings, but it admits some naivety around what was had already been done. So we sort of thought of this agent-specific utility on our own, but it's good to know that is an established approach that others have taken for many years. And yeah, we wanted to build a front end, so a web application, and then also a command line interface just for making things easy. This is our team, the Quantex NLP team. We work on many topics across NLP, but we also work on applied AI stuff. So the DSL that we came up with, it looks like this in a nutshell. I realize that's very small, but effectively what you do is configure all your agents and the hyperparameters of the simulation. So these are things like how many times it should run. It's quite flexible in terms of you can subclass agents and you can subclass the simulations themselves if you want to add things or tweak how it works. Most importantly though, every subclass of agent implements a utility function which it results in a scalar score. But other than that, we're completely agnostic around what that utility function should be. And so sorry, I just want to say one more thing, which is the strategy field of agents is private, and we are very careful to unit test that and to test in the framework that information really does stay private. Yeah, maybe I can just quickly show you the UI live, and then we can discuss anything else in the poster session. So this is what our little UI looks like. So you can configure simulations, and once you do, they spin off and they sort of run for as long as they need to. And while it's running, you see a little dashboard. You can see the live conversation of each round of the simulation. And then at the end, we try to build this very flexible dashboard for seeing some metrics of the simulations. So you can select different outcomes, and these are simulation specific. So final price is specific to this simulation. You might have a different value for a different setting. I tried quickly to simulate a scenario where it's multiple agents sitting around a restaurant table with a spinning table in the middle, and there's lots of food, and different agents want different food. Just for fun, we have this AI generation thing. So it worked and it came up with agents, but the outcome is a little bit underwhelming, but still it's funny. I mean, they're trying to negotiate around who's going to get vegetarian versus who's a carnivore, etc. But I think it would need a few more tweaks. I just did the AI bootstrap here, so I think it would need a few more tweaks to actually have the agents optimizing in terms of trying to get the most food or whatever. I'll stop there for now, and we can discuss more in the poster just so that I don't need into the coffee break. Cheers, thank you.